Hey guys, this is Miss Samra back again with my new lesson today. So first of all, I would like to thank all of you guys for beautiful comments. It matters a lot. Seriously, it mean a lot to me. So thank you. I'm trying to help. So please let me know if there's anything I can do to make it better next time. Anyways, all right. So let's get started with our next lesson today. And my next lesson is on 3-6. And this lesson is all about compound interest. I hope you guys remember in first two sections we talked about this before. So we talked about how the equation comes, where do we get those one from? We get one plus something, growth and decay factor. I hope you guys remember that. So you can always refer back to your notes from first two sections just to make it easier. You could do that. So all right, so today's lesson is about compound interest. So compound interest is just a second, hold on. So compound interest. I hope you guys remember that equation was like this. A is what you get after a certain number of years. P is what you start off with, means that's the principal balance. And it's 1 plus R, and then it's T on the top. Now, the reason it's 1 plus, because this makes this expression as growth factor. So I hope you guys remember, if it's minus means it's something that decreases, and this would be decay factor of that function. So now here's something we're gonna do different this time. This is the equation when this compounding process happens once a year. But let's pretend this compounding process happened multiple times. So this compounding happened multiple times. Multiple times. Okay, let's say this is my equation. This is A and this is P. This is 1. Okay, now let's say this compounding process happens monthly. If I say monthly. So you know this is going to be R. Okay, before this rate was split up in one part. It wasn't actually, I would say it wasn't even split up, means it was just for one whole year. After that, it was getting compounded, and that's how it goes. But this year, let's say, if it's compounding monthly, means this rate's gonna be split up into 12 pieces. Instead of one whole, it's split up into 12 pieces. And let's say you invested for 5 years. So it means now in a year it's happening 12 times. So if you invested for 5 years, so it means in 5 years it's happening 60 times. Why 60? Because every year this compounding process happening 12 times. So for 5 years it's happening 60 times. So it means the same number would go up here. So this would be my new equation. So let me just write a general equation. It would be A, it would be P here, 1 plus rate, and this time stays the same. But now there's a piece that's going to get added to this equation. Let's just say this is K, and this same K would go up there. And what is this K in this equation? So K is equal to number of compounding periods. Number of compounding period. Periods. Okay, so basically this case going to be different based off what problem you're looking at. So let's say if this compounding is happening monthly, this K would be 12. If it's happening daily, then this K would be 365 or 366, depends if it's a leap year. Let's say it's happening quarterly, then this K would be 4. Let's say if it's semesterly, then this K would be 2 because we have 2 semesters in a year. And let's say if it says annually, annually means it's happening once a year. So pretty much K would be just 1 in this equation. All right, so I repeat, it's the same equation we started off on the first section. So basically, it's just this number that's added on to this equation. So based on compounding period, so this K would differ. So if it's monthly, would be 12, daily this, quarterly, semester, annually, and so on. Okay, let me talk about other equation too. So let's move on to another equation for compound interest, which is commonly known as PERD. So this is how we write this equation. A is equal to PERD. And don't forget, common mistake. This is where people normally write it as, which is not right. This is not right. This is how we write PERD. So it's the principal balance, then E stays the same. So RT is the exponent for that function. Okay. All right. So let's look at my first example. And if you want to follow along, so I'm on page number, this is page number 334, and I'm looking at example number 1. So I have a helper here, will help me reading. He'll just read this problem to me. And Harjus, could you just help me? And could you just read this for me, please?
Suppose Quan Lee invests $500 at 7% interest compounded annually. Find the value of her investment 10 years later.
Oh, thank you, sir. I really appreciate that. So I have principal balance of $500. Then I have 7% interest rate. And we want to know how much she'll get after 10 years. So the time period she invested for is 10 years. Okay. Since it's compounding annually, so means the K would be 1 this time. So it would be A. This is what she's going to get. Principal amount is 500. This is 1 plus rate. Oh, you remember 7% means you need to move decimal 2 places to left. So it would be 0.07. And then if you divide by 1, it would still be the same number. So I don't have to write this number, anything under that. And T is just 10 years. So let's just type it in the calculator. So if I do that, I get 983 and 58 cents. There you go. So that's my answer for the first one. Now let's look at another example on compound interest. So hold on. So let's say, just a second. My helper is ready to read that for me. Thank you, sir. Okay. All right. So I'm on example 2. This is page 335. Go ahead, helper.
Suppose Roberto invests $500 at 9% annual interest compounded monthly. That is compounded 12 times a year. Find the value of his investment 5 years later.
Oh, thank you, sir. I really appreciate that. And okay, so this is what I have. So I have principal amount of $500. Rate is 9%, which is 0.09 later on. And then time is 5 years. Time is 5 years. And it's compounded monthly. It means this K would be 12 in this equation. All right, so let's plug everything in. So A is what we get. So 500 what we started off with. It's 1 plus rate, which is 0.09. This time we'll divide this number by the K value, which is 12. So in 5 years, it would happen 60 times because this 12 would get multiplied by 5. Now let's solve. 500. So you can even combine this whole part first, or you can just type it in your calculator. So either ways, it's fine. You can type in the whole thing. And if I do that, so my answer is 782 and 84 cents. There you go. I have one more example. So helper, get ready. You gotta read one more for me. Just a second, I'll let you know. Almost there. Could you read example 5 for me?
Suppose Latasha invests $100 at 8% annual interest compounded continuously. Find the value of her investment at the end of each
For 2
30
years.
years.
All right. Thank you, sir. I appreciate that. All right. So this is what we have. So the principal balance of $100. Rate is, this is principal balance. Rate is 8%, which is 0.08. And it's compounded continuously. I hope you guys remember that's the key word in this problem. And anytime it says continuously, it means it's the paired equation this time. And she invested for 2 years. So 2 years. So let's just write down the equation. A is equal to P, which is 100. E would stay the same. Rate is 0.08 times it by 2. If I tap it in my calculator, so let's say it's 100. Then it's shift and ln 0.08 times it by 2. And my answer is 117.35. And here you go. That's what I have. All right, guys, this is all for today. Thank you for watching. All right, bye-bye.